Hello everyone. Welcome to Progressive Education Society's Modern College of Pharmacy. Today we discuss about ion exchange chromatography presented by Yash Kulkarni, Santoshi Lashkare, Omkar Lokhande from final year B Pharm Division A. Subject Instrumental Method of Analysis. Today we discuss about ion exchange chromatography, introduction, classification, methodology and application. Introduction. Ion exchange chromatography can be defined as a reversible process in which ions of similar charge are exchanged between solid and liquid. The solid is known as ion exchanger. It is an adsorption type of chromatography and useful and popular method for separation of mixture of similar charged substance into pure components. It is also known as cation-anion exchange chromatography. Definition: these are the substances capable of exchange of ions with electrolyte solution. These are porous solid swelling in water without dissolving in it. The most common properties of ion exchanger are as follows. First, they are almost insoluble in water and organic solvent. They are complex in nature. They have active or counter ions that will exchange reversibly with other ions in a surrounding solution without any substantial charge in the material. Types of ion exchanger. These are the three types of ion exchanger, which includes resin, gel, inorganic exchanger. Resin. Resin are the amorphous particles of organic material which are composed of polystyrene and divinyl benzene. Polystyrene consists site of exchangeable functional group.
Classification of resins. According to their chemical nature, they can be classified as strong cation exchange resin. These types of resins are useful for the chromatographic separation of amino acids, rare earths, and other substances that contain sulfonic acid group as the ionizable group. Weak cation exchange resin. These resins are based on polymers of methacrylic acid and possesses carboxyl group. Strong anion exchange resin. These resins with positively charged quaternary amino groups attached to the cross-linked polystyrene frame work belong to these class. Trimethyl ammonium groups are used for these resins. Weak anion exchange resin. The tertiary amine resins and polyamine resins have mixture of primary, secondary and tertiary amine groups on polystyrene network are well known. According to the source, they are classified as first natural source, cation, example zeolites, clay, etc. B. Anion, dolomite. Second, synthetic sources. These are two types. First is inorganic resins, second is organic resins, which are most widely used. Third is structural type of ion exchange resins, that is pellicular type with ion exchange film, porous resin coated with exchanger beads, macroreticular resin beads, and last is surface sulfonated and thermostatically bonded with anion. Properties of ion exchange resin. It must be chemically stable. It should be insoluble in common solvents. It should have a sufficient degree of cross-linking and the swollen resin must be denser than water. Also, it must contain a sufficient number of ion exchange group. Second, gels. Ion exchange gels are used for the separation of large molecules like proteins, nucleic acids. They are much softer than polystyrene resins. Dextron and its relatives are gel. Cellulose and dextran ion exchanger, which are polymers of sugar glucose, possesses large pore size and lower charge densities. Third, inorganic exchanger. The combinations of hydrous oxide of highly charged ions with one oxide more acidic than the other have been found to have ion exchanging properties. The amorphous precipitates have higher exchange capacities than the crystalline compounds because of their greatest surface area of the former types of compound. For example, titanium arsenic has been used to absorb alkaloids. Mechanism of ion exchange process. The mechanism of separation is by reversible exchange of ions between the ion present in the solution and those present in the ion exchange resin. Ion exchange separations are mainly carried out in column pack with the ion exchanger. There are two types of ion exchanger as follows. First one is the cationic exchanger. It possesses a negatively charged group and that will attract the positively charged group. These exchangers are also called as acidic ion exchange material. Such, their negative charges result from the proteolysis of acidic group. Commonly used cation exchanger resins are sulfate derivatives and carboxylate derived ions and etc. Second is anion exchangers. It has positively charged group which will attract negatively charged molecule. This exchanger is termed as basic ion exchange material since their positive charge generally result from the association of the protons with the basic group. Based upon the affinity of ion towards the matrix, the ions like cation and anion are separated. The ions that have less affinity towards the matrix will elute first and the ions that have more affinity towards the matrices will elute later. Commonly used ion exchange are quaternary amine and diethyl aminoethane resin. As you can see in the figure, first is the initial stage. At this stage, the ion exchange resins is equilibrated with a countarian, that is the yellow circle from the buffer solution. These countarians balance the charges on the resins. Second, the absorption of target ions. When the sample is introduced, the target ions, which are represented by the green circle along with the other sample ions that are blue squares and red triangles, start interacting with the resin. The ions with the opposite charges to the resins, that is green ions, which are more strongly attracted to the resins than the countarians, display the yellow countarians and bind to the resin. Third one is the start of elution. During the elution stage, a gradient is applied. This causes the ions that are weakly bound to the resin to begin eluting. The stronger binding ions remain attached for now. Fourth one is the end of elution. As the elution continues, all target ions that are green circle are displaced from the resins by ions from the buffer or the gradient. The non-target ions that are blue squares and red triangles are still retained on the resin. Fifth one is the regeneration. Finally, the resin is regenerated by washing it with a solution that replaces the sample ion with the original countarians that are yellow circle. This restores the resins to the initial stage, that is ready for the next cycle. Factors affecting ion exchange. First is nature of the ion exchange resins, that is cross-linking, and the swelling is important factor which depends on the proportion of the cross-linking agents. For example, polystyrene and divinyl benzene. Second is the nature of exchanging ions, that is valency of ions, concentration of solutions, concentration and charge of ions. Let us talk about the methodology. First one is the initial binding. The column contains positively charged gel beads. When the sample containing both positively charged molecules that are purple circle and negatively charged molecule that are pink circle is introduced, the negatively charged protein binds to the positively charged beads due to the electrostatic attraction. The positively charged protein that are purple do not bind and immediately efflate, that is flow out with the initial buffer solution, as they are repelled by a positively charged bead. Second is the low salt elution. Initially, the negatively charged problem remains bound to the beads. At low salt concentration, some weaker interaction may start to break, but the strongly bound proteins remain attached to the beads. High salt elution. A high salt solution is then added to the column. The high concentration of ion competes with the negatively charged protein for the binding sites on positively charged bead. The competition displaces the negatively charged proteins from the beads, causing them to elute from the column. Column used in laboratories are made up of glass, but those used in industries are made up of high quality stainless steel or polymer, which are resistant to strong acid and alkalis. A dimension of column is 2:1 or 100:1 for higher efficiency can be used. Packing of the column. In this, wet packing method is used. The resin is mixed with the mobile phase and packed in the column uniformly. The sample to be separated is dissolved in mobile phases and introduced all at once in the column. Application of the sample. After packaging the column, the solution to be analyzed is added to the top of the column and allowed to pass through the bed of the ion exchanger. For the purpose, the syringe or pipette is utilized or used. Mobile phase. The organic solvent are less useful, so they aren't used these days. Only different strength of acids, alkalis and buffer are used as eluting solvent. Example 0.1 NaCl, 1 NaOH and phosphate buffer, acetate buffer and etc. Development of chromatogram and elution. After the introduction of sample, development of the chromatogram is done by using different mobile phase. The aqueous salt solution is adjusted to the constant ionic strength. The choice of the mobile phase depends on the selectivity of the resins for the solute ions. Analysis of the elute or detection. Different fractions are collected with respect to the volume or the time is analyzed for their contents. Several methods of analysis can be used which depends on the nature and the quality of ionic species are conductometric method, amphometric method and flame photometric method and polarography. Regeneration of ion exchange resin. The ion exchange resin after the separation may not be useful for the next separation as exchange functional groups are lost. But due to the cost of ion exchange resins, they cannot be disposed of. Hence, reactivation, regeneration of the resins is most important. It refers to the replacement of the exchangeable cations or the anions present in the resins. Applications. First is the softening of hard water, that is hardness of water due to the presence of calcium, magnesium, other divalent ions may be removed by passing through the hard water through the cation exchanger charged with sodium ions. Second is complete demineralization of water. This requires a complete removal of anions, both cation and anions. For this, water is passed through an acidic cation exchanger, then metallic cations are exchanged with the hydrogen ions. Third one is the purification of organic compound. Many natural products extracted in water have been found to contain ions originally present in the water. These ions can be removed by using ion exchange process. Fourth, separation of amino acids, that is ion exchange method can be used to separate the complex mixture of 18 amino acids obtained by the acid hydrolysis of protein. Fifth, purification and recovery of pharmaceuticals. The process is used for purification and recovery of antibiotics, vitamins, alkaloids, hormone and other chemicals of pharmaceutical importance during the manufacturing process. Sixth one is the biological separation, used for the biological separation like some drugs or metabolic from blood, urine or other biological fluids. Lastly, other applications for the measurement of various active ingredients in the medical formulation, such as measurement of the additives such as vitamins, preservatives in the food and beverages. Thank you.